Now we will look at installing the IDR300 spectroradiometer in its DC configuration. So we should site the IDR300 on a suitable location. We recommend with the mains and USB forward facing. In that manner, the detectors, which are situated to the rear and to the side, are out of harm's way. And furthermore, in this way, the entrance will be through this port to the left. So it would be ideal to locate the IDR to the right hand side of the bench, and that way we have a working area to do measurements of sources. We will proceed with fitting the DH3 photomultiplier tube to the right hand port, the exit of the second monochromator, the DHSI silicon photodiode to the second exit of the second monochromator, and the DHIGE3 lens in-gas photodiode to the exit of the first monochromator. And equally, we will fit the fiber bundle adapter plate to the entrance slit. In order to perform that and show the electrical connections, I will now turn round the IDR300. So now, with the IDR300 turned round, we can proceed to install the detectors. Firstly, we have the DH3 photomultiplier. It is provided with 3 M3 screws which adapt to a plate to the exit port of the double monochromator, and a M3 screw driver has been provided. And we should ensure that the attachment is very firm, because we want to make sure that this detector, which is very, very sensitive to low levels of light, sees no light leak through the interface to the IDR300. And next to it, we fit the DHSI photodiode. We have 4 M2.5 screws provided, and we attach that next to the photomultiplier. These 2 detectors we will never need to remove, so we can make sure they're very well attached. To the exit of the first monochromator, we will fit the DHIGA3 lens in-gas photodiode. Now this one we will remove occasionally when needed to go to the infrared measurement, and there fit the lead sulfide detector. So for the moment we shall install the in-gas photodiode. And finally, the adapter for the fiber bundle. It's most convenient to keep the grub screw uppermost, and this grub screw is used to retain the fiber bundle when it is installed. Again, this will remain in place for most of the time, but it needs to be removed for the measurement in the infrared, whereby we position at the entrance port an infrared relay optic. We'll now look at the electrical connections. Now, in terms of electrical connections, we have to the base of the IDR300 2 dual input transimpedance amplifiers and a high voltage supply. The high voltage supply is required by the photomultiplier in operation, and also the lead sulfide detector for use in the infrared. Starting with the high voltage, we have a thick BNC cable with PTFE inserts to avoid inadvertent connection to other BNC sockets, which will connect the HV labeled port to the labeled HV port on the photomultiplier. A cable, a thinner BNC cable of the same length, is provided to connect the signal of the photomultiplier to input 1. And two other cables are provided, one to connect the silicon photodiode to input 2, and the in-gas photodiode to input 3. The fourth input is reserved for the lux meter, the DH400 photometric detector, which is provided for the determination of the 500 lux distance, and this can simply be connected to the lux meter port. We have now set up the IDR300 spectroradiometer with regard only for the input optic to define the geometry of the measurement we are going to perform, with a range from 200 nanometers to a maximum of 1700 nanometers, although in the typical configuration we only use this detector to 1400 nanometers. One final and useful point to make is with regards to the fibre bundle insertion. It should be noted that the fibre bundle has a rectangular ferrule to adapt to the rectangular entrance slit of the monochromator. Now, the monochromator has motorized slits which close down to a fixed park location on initialization of the software. Structures holding the slits are located to either side of the ferrule. One final and useful point one should make is with regards to the installation of the fibre bundle. We have two different fibre bundles for the measurements of irradiance, spectral check, and radiance, both of which have the same design of ferrule. It is very important that if a fibre is not currently installed at the entrance slit of the monochromator, we should run the software and initialize. This procedure will close the slits of the monochromator, and then we can fit the fibre bundle in, push it as far as possible to reach as close to the slits as possible, ensuring no loss of light. Were one to install this fibre bundle when the slits are open, then the orientation of the fibre may be incorrect, and this may impede the slits from closing. The initialization process will result in an error which one does not want to encounter.